Howdy doody, neighborinos. Okay, so we had a question. We had a question about creating a table of half reactions. So number 5 in the predicting redox reactions Google form said was asking list all of the oxidizing agents from strongest to weakest. That's basically what it's saying. And so okay, let's go through here. Let's go through here and let's try and see if we can't create a table of half reactions. The basic principle to a table of half reactions is oxidizing agents are always on the left-hand side and reducing agents are on the right-hand side, and you always put the strongest oxidizing agent at the top and the weakest oxidizing agent at the bottom. You always put the strongest reducing agent at the bottom and the weakest reducing agent at the top. And so basically the way I do this is I see who won the battle for the electrons, and then I put the oxidizing agent version on the left and the reducing agent version on the right. That's all I do. So who won the battle for the electrons? That's what I'm asking. Let's go through the first one. Cerium has electrons that it could give, strontium has electrons that it could give to cerium. Now, does cerium successfully steal those electrons? Well, cerium ends up with the electrons. It ends up with the electrons. So this is the oxidizing agent, and that's the reducing agent, right? In this particular reaction. So what's going to happen is cerium is successful in stealing the electrons away from strontium. So I'm just going to make a table here, and I'm just going to say, okay, Ce3 plus is higher. Ce3 plus is higher than whatever the oxidizing agent version of strontium is, which is Sr2 plus. Sr2 plus. And I'm going to give a bunch of room here because I don't know what else is going to go in between, or if anything's going to go in between. Now next we've got nickel and hydrogen ions. Now hydrogen ions are successful in stealing the electrons away from nickel because they end up neutral, or they end up with a more negative charge. But I don't have either of those two things here, so I'm just going to put hydrogen ions off to the side and nickel, because I don't know who's going to end up higher or lower, whatever. Now, here we go. Cerium 3 plus and nickel. Cerium 3 plus and nickel. Who should be higher? Okay? Cerium 3 plus wants to steal nickel's electrons, but it's unsuccessful. There's no reaction. Cerium 3 plus is not a strong enough of an oxidizing agent. So put nickel higher. So we're going to take nickel. We're going to take nickel and we're going to drag it higher. So I'm going to put nickel 2 plus. Well, who was higher than nickel? Hydrogen ions were higher than nickel, right? So we're still maintaining hydrogen ions are higher than nickel. Hydrogen ions above nickel, nickel above cerium, cerium above strontium. We still have everything in order right now. Let's look at the last reaction. Platinum and hydrogen ions. Hydrogen ions want to steal the electrons away from platinum. Are they successful? No. So who wins the battle for the electrons? Platinum or hydrogen ions? Platinum does. So platinum needs to go up at the top. And we don't know what charge it could be because there's no reaction. So you just look at the answer, but we know it's going to be positive. Platinum plus, platinum 2 plus, platinum something, whatever, okay? So now I'm going to say platinum plus turns into platinum when it steals electrons. Hydrogen turns into hydrogen. Nickel turns into nickel. Cerium turns into cerium. Strontium turns into strontium. And all of these are the reducing agent versions of the oxidizing agents. So let's go back through this table. S, strongest oxidizing agent and weakest oxidizing agent, weakest reducing agent, and strongest reducing agent. Let's go back through the table and let's see, does this make sense? So find strontium atoms and cerium ions. Strontium atoms and cerium ions. This reaction looks like it's spontaneous. Is this reaction spontaneous? Yes. Good. That makes sense. This table makes sense with what we see in the information given to us. Nickel atoms, so I'm going to do this in blue, nickel atoms and hydrogen ions. Nickel atoms and hydrogen ions. That's downhill as well. So yeah, that should be spontaneous. Good, no problem. And delete those. Things are going to get crowded. Okay, let's do this in green. Find cerium ions. Find cerium, cerium ions right here, and find nickel atoms. Nickel atoms. Is this a spontaneous reaction? No, and that's good. We don't see a reaction. That's non-spontaneous. So far, the table that we made is matching with the information that we're given. Okay, and then the last one, I'll do in black. So the very last one, is platinum atoms, and hydrogen ions, and that is also non-spontaneous, so that works. Okay, so everything that we're looking at here, the table here matches with everything that's given in the data there. Now, if we want to write these from strongest oxidizing agent to weakest oxidizing agent, what's the strongest? Platinum plus, 1 plus, 2 plus, whatever, it doesn't matter. Platinum plus, then hydrogen plus, then nickel 2 plus, then cerium 3 plus, then strontium 2 plus. And it doesn't matter what the charge is, as long as it's that charge, that positive charge. So when you look at your answer, you see that platinum has a 2 plus charge. Oh, fine, whatever, it doesn't matter. 2 plus charge. Like, we don't know what it is, but it doesn't matter. So this is the correct sequence of strongest oxidizing agent to weakest oxidizing agent. Let's just recap just for a second. You look at the reaction, just look at whatever the reaction is here, and you put whoever wins the battle on top. Now, if there's no reaction, then that means whatever didn't lose electrons goes on top, right? So let us know if you have any questions. I don't know. Hopefully this video made sense. Maybe it didn't. Let me know if it did. Let me know if it didn't. Perfect. Thanks a lot. See ya.